Okay, welcome back to the series creating an RPG SDK. In this video, we're actually going to start creating the code to call the get API to fetch information about beers, which is awesome. I really can't wait, actually. It's going to be fun. So, in the last video, we decided just on some generic kind of APIs that we're going to create. And we'll start with the very top ones, which actually gets the data. And I think that will be what this video is about, the get API specifically. Sorry about that Slack message there. The get API specifically. And so that's that's the very first thing we're going to do. It's a procedure, takes 3 parameters, and they're all optional. So that means we can use options no pass. And well, let's build the API. It's going to be fairly simple. Of course, we're going to do a declare procedure, and it's going to be beers get, and of course, it's going to be export, and we'll do an end proc. So the PI, I always like to use the name in the PI. Some people like to use *n, which is fine. It returns a pointer, fairly simple, and it takes 3 parameters. So that's, it's pretty straightforward. So it takes a beer name, a page, and then per page. So I think what we'll do for this, we'll take p beer name, or let's do p search, and it'll be a pointer value options string. Now the reason for that is so they can pass in, we don't have to worry about how long or whatever data they pass in. So we can, make it easier for the user to use. It also takes a page number. So in this case, we'll use an integer, so p page, and that will be, let's say, int 5, and that will be a const, and we'll also do p per page. And as you can see, I like to format my parameters quite easily. Also int 5 const, and that's all the parameters for it. Now, no, it's not, because we also need to make them *no pass. So it also needs to be options *no pass. And we'll just copy that and repaste it below. So that's our parameters. Fairly simple. Now, the important part is that we also declare a variable for the parameter, or the sorry, not the parameter, the URL itself. So we'll just call it URL, and we'll make it a variant length character. And we'll make it 128. I think that should suffice. Now, for the initial value, we'll just make it this. We'll make it the /beers. That's what we're going to make it. So we're going to say URL equals the endpoint. Save. Excellent, excellent. So of course, when even though we have the URL, we need to accept piece that we actually need to be able to pass in p search, p page, per page. So that's going to be fairly straightforward. So we're going to do if %palms is more or equal to 1. That means they've passed in a search parameter. Now, they may not actually want to pass in a search, but they may pass in a page. So I think what we'll have to do is add another variable here called search. We'll make this variant length character, and we'll make it the max length of, let's say, 16, because shouldn't be searching anything that long. Of course, we can change that later. And we're just going to say search is the string at the p search pointer. So that'll be the null terminated string that they pass in. And then we're going to say if search is not blank, and if we need to append it onto the URL. So pretty straightforward, but we need to do a couple of things here, because if the URL already has a question mark on it, of course the question mark has to be the first value. As you can see, has to be the first value, and then the split between each parameter is an and sign. So how should we do that? That's an interesting question. Well, of course, the easy part that we could do right now is just to say URL plus equals question mark, and then we do what is the actual parameter? It's beer underscore name equals plus search. So that would be the simple way to do it. But it's this question mark that worries me a little bit. So what we're going to do is this is a very simple way of doing it. We're going to say split equals, Oh no, not equals. This isn't C. We'll make it character 1, and initially it will be a question mark. So what we'll do is we'll just say plus equals and then split plus that, and then if they do add it, we'll just set split to the %. Fairly simple, pretty straightforward actually. And then we just need to do that with the other one, so page and per page. So what are the per page parameters? It's going to be page and per page. So that's fairly simple. I'm just going to copy most of this here and paste it in. And of course, I'm going to change it so this says 2. And because these are just numeric, what we can do is say it's not ever going to be blank. So if there's more, we can say URL plus split plus is page first. Yep. Page equals character and then p page. And of course, I like to do my uppercases on my built-in functions. That's fairly simple. And then we'll do one more. If it's free, then we can say per page is, p per page. That's it. That's really everything to building the URL. Now, I am wondering if we should also make the URL a bit longer, but we can come back to that a bit later. It's not very important right now. So that's pretty much the majority of actually calling the API, which is really nice. It doesn't have it's not a post request, so we really don't have to worry about too much. There's also no headers for the API, so we really are very lucky here. Now, to call it, we're going to use embedded SQL. So that's really the fun part. The very first thing we're going to do is declare a response variable. But it's not going to be a regular varying length character. Or is it? We could make it varying length character, I suppose. It doesn't need to be that long. So let's just say varchar. Let's just make it 16,000 characters. Okay, because you never know how big these APIs are going to be. And we're just going to say here response. Actually, this has to be an embedded SQL statement. So exec SQL, and we're going to say set our response equals systools dot http get clob, and this takes 2 parameters. The first one, it doesn't even need to be on a new line, but the first one is going to be our URL. So that's the colon, and then URL. That's our host parameter, and then blank, and that's it. So now if I save it, it's going to take a second to save, and then that's pretty much it. So we just need to return a pointer, really, at the end of the day. So if we just take that out for now and just save it, and what we're going to do, iEditor has this really nifty feature called compile, called live errors. And if you put the compile type, create SQL RPG I_mod, that's the compile type, and I save it, what that does, it does a little compile check without actually having to compile the program. Now, if there are any errors, we're going to know about it. So there are, that's okay. And what do we got here? End if. So it looks like we might be missing something. So this is the end of its expression. Yeah, that's because we're missing the semicolon there. So if I save it again, I don't know why the saving is taking so long tonight. It's very odd, but that's okay. So now that fixes up the errors. That's really great. It looks like our embedded SQL, and that's okay. So that looks good. Now the next part is actually returning the JSON pointer. So that's fairly simple, actually. We do need to actually bring in the copybook for the JSON XML. Now, because we're obviously working out of source members, this will be qrpgle ref, comma, JSON XML. It's case insensitive, so we can just save that, which is great. And then that means that we can now use the JSON XML APIs, which I love. Oh, sorry. I need to put it below the control opt there. There we go. Let's save it. Again, that's one of the great reasons about iEditor. I didn't need to... no return type. Oh, I see, because the pointer, yeah. So that's the next part. The next part is actually quite simple. So now we've brought in the copybook, we can use the JSON XML libraries, the NoxDB libraries. All we're going to do is make a JSON pointer. Very simple. And then all we're going to say is JSON equals JSON. response.parseString, I think the API is off the top of my head. And all we have to do here is pass in the response, which is excellent. So we can just save that. And then, of course, we can return JSON. Oh, we have an error. Not defined. Okay, so that means I've probably got it wrong. So let's go look at the actual APIs for it. So if I just search for parse, and I'll just have a scroll here. Parse file, parse string. Oh, this is the wrong header. Oh, blimey. So I would have corrected this already in the last video, but I may have pulled down JSON XML. Yeah, I did. So I'm going to head back over to the NoxDB library. And I'm going to go into headers. And I want JSON parser.rpgle. Now I'll leave the name as it is. I'm just going to copy that. Now the difference here is that this has the JSON names. So it has just better names that are more suited to this. Now I'm going to save it, and it's going to have some issues because of the what am I saying? Because of the record length here. So I'm just going to go ahead and fix those. In fact, we don't even need that one. Oh, there we go. And that should save it. So that will fix the issue. Now I've updated the JSON XML. Now I'm going to probably make that patch in the other video already. So now if I save it, the compiler error should go away. Hopefully. Yep. So now we can use parse string, and that's awesome. And we have our response, which is awesome. So now if I compile it, it's compiled successfully. It hasn't made the service program, but it's made the module, and that's really all we care about right now. Now, while we're here, let's also work on beer count and element at and string at. So this is just to get information out of the JSON, basically. And we'll start with beer count. So let's do a duckle proc beers count. And it's going to be, of course, ext export, not exta proc. And this will take one parameter, which is the pointer, beers count. And it will return an int 5. Of course, it could also return an unsigned, but I won't do that. And we pass in we pass in an array. So that's going to be a pointer, fairly simple. And all we're going to do is return JSON, and then there's an API in the JSON XML header. JSON XML header, and I think we'll just search array. Now it might take a moment to find it. Array push, array append. Maybe it's get size. If I search size, we might find it. Nope. Okay. Get string, new array, array push, array append, array slice, array sort. Look up, get length, that's the one that we want. And it does return an int 10, so we could just save the effort here and just return an int 10 as well. And then we're just going to do JSON get length p array. Now again, we can do this because the JSON that comes back from the API is an array, as we saw in the documentation. It's always an array. So that's cool. That's really all we want. And of course, I'm pedantic, so I'm going to correct the sizing here. Okay, and then we also want to do a beers element at export end proc. And then we want to be able to pass in the array and then an index. So we can just copy this actually. And we want the array, and then we want a p index, which will be character, let's just say 5. No, not character 5, sorry. Let's do int 5. Kind of go blank for a second. Const. Okay, and then we're going to do a return. And there isn't an API to get a specific index, but the best way to do it is like a locate, JSON locate. Makes things really easy, and we can actually just do a return JSON locate, and we pass in p array. And then we can say, now this is interesting because NoxDB does actually allow you to pass a string expression to find a property in your object or the array index. So, like for example, even if I search index, there's no way to get a specific index. So locate or create generally is an easy one to do. Get parent, yeah. So I'll just do the way I do it. I'm going to pass in a square bracket and then append the character of p index, and then add an extra bracket like so. And that will return a pointer, not an int. That will actually return a pointer. That will return a pointer to the object. And then we'll end up with one more. We'll do one more, and that will be string at. We'll start with string at. So declare proc biz string at export and proc, and then of course we're going to add a call pi biz string at. This will return a variant character, and we'll make it, because the strings for the description are quite long, we'll make this variant character 256 for now. Of course we can change that later. So what we're going to do is we're going to pass in the p object. That will be the object that is returned from the element at, and then we also want to pass in the property name. Now we can use the something like p search, where we use the pointer value option string. We can use the exact same thing here, and I like to say property. Very simple. And then we can just do this: return JSON, and I think it's just get str, where we can pass in the same like so. Save. And of course that's going to save, and it's going to run its compile check, although I believe everything is correct. But I suppose we'll wait whenever this save would like to finish. Now I like to do a couple of other things in the code. What I'm going to do is just add some comments to just make it more obvious where the procedures are. Like so, very simple. I'll just put those between the procedures. I'll save that. And that's really kind of where I wanted to start. So I'm going to go ahead and compile this, make a service program. Now my session is probably timed out, so I'm going to reconnect here. This is the longest video yet. So first of all, let's compile it. Now it knows what it's compiling because, again, we actually use the compile keyword as a comment. This is something, an iLetter2 feature here. So this is running a create SQL RPG underscore mod, and then we want it to be able to run create serve pugum as well. So let's just prompt this. The service program, that's obviously going to be Punk API. The lib will be Punk API as well. It will be the same as the service program module. Export, I'm just going to do star all. I'm not going to create any binding information here. And that's fine, that's my own choice. Binding directory, I will pass in Punk API, although we'd already have it defined in the module, I believe. Yeah, we do, but that's okay. So I'm going to take it. It won't do anything. I'm just going to copy this. Although I believe it does already have a create serve pugum, but I like to use the I'm going to make another one, create serve pugum bind, which really will just have the binding directory parameter in there. Now I'm just actually going to take and copy a lot of this and replace it. So I know that my binding directory is the same as my API, so I'll just save it like that. Save. So now I have, I actually need to take out the compile option for this, funnily enough. So I'm going to take it out and save it. Takes a second for some reason, that's okay. So when it's saved, I can take Control E, and I see I have create serve pugum bind. So I can use that, and that actually compiled successfully. So now if I go to work, obj, punk API /start all, now I have my Punk API service program, and that is the very basis of an SDK. Now in the next video, we're not done yet. We're going to write our first test program to try and get a set of data, which is exactly what we want. So let's do that, and thank you very much for watching.